Good afternoon, everybody. Welcome to this talk of contributing to the AWS Construct Library. My name is Lee Packham. I'm a senior developer advocate with Amazon Web Services, specifically working with developer tooling, which includes software development kits, including the Cloud Development Kit, which we're going to be talking about today. With me, I have Rico, who is a software development engineer on that project and is one of the core team members. We're going to spend most of our time today actually looking at doing a contribution to the Cloud Development Kit. So we're hoping to spend most of the time today doing more of a live demo type approach and actually going through coding a contribution to the CDK. But before we dive into that, sort of want to look at what the Cloud Development Kit is, sort of give a really brief overview of that, look at how the CDK and open source go together and how open source has really worked with the CDK project to turn it into what it is today. And then we'll dive into our demo. But first, I'm going to hand over to Rico to talk about the CDK itself.
All right, thanks. OK, so to make sure we cover the basics, right, let's go over what the CDK is real quick. So in case you don't know, the CDK is the thing that allows you to write something like this, right, like a couple of lines of high-level code that clearly expresses your intent in one of various languages that we support. And this defines and deploys like a complex architecture with not a lot of effort, right? You can write this in a couple minutes. So I'm interested, can I see a show of hands who has used the CDK before here? That's a good show. All right, thanks. If you've used it, you'll be familiar with the benefits, right? You get to work in the language you know. Using the language constructions, you already know for expressing yourself, you get to use classes and methods. To introduce abstraction, you get to use for loops and all the simple things you do. What's more, you get to work in your favorite editor. And you get your tool support for your language. And generally, tool support for general purpose programming languages is really good, right? You get autocomplete. While you're typing, you get inline documentation. You get red underlines to tell you when you've made a mistake. And then finally, we spend a lot of effort in CDK crafting the class library to make you as productive as possible, to make sure everything comes with sane defaults, designed for you to be as efficient as possible. And if what we've done is not enough, or you want to write something that you want to distribute inside your own company to encode certain standards, you can do that as well. You can just add your own abstractions and share them around. One thing we're very excited about, and we think is very important, is that the CDK is open source and has been from the start. We want to show there's no secrets. What we've built, anybody can build. We've taken the lead. You can see exactly how it works, and you can participate. It's not like we work on this internally and then dump the source code every so often to a place where you can read it. We do all our development work there. You can see how we interact with each other. You can see us making changes. You can see us code reviewing to one another. You can participate. You can tell us what you would like to have done. You can upvote tickets. You can create them. You can submit your own pull requests. This is our web address. This is on GitHub. And this is where we interact with everybody. So let's see how this has been going for us so far, like a little peek under this. We've started this about a year and a half ago is when we went public. So that's roughly 19 months. And in that time, like the uptake has been great, like almost 700 people. And these statistics are a couple of weeks old. And I wouldn't be surprised if the numbers are a lot higher by now. Around 700 people have used this and have told us how they feel and what was working in CDK for them, what is not, use cases that aren't covered, maybe sometimes bugs that they found. They reported it. Close to 1,500 issues have been created. And this is by non-Amazon employees, by external people. All right, so this is amazing to me. Can I see from the people who've used it, has anybody in the room created an issue for us before? All right, a couple, thanks.
Cool.
For the people that have used the CDK and did not create anything yet, were you aware that you could? OK, not a lot, right? So that's great. Thanks. This session is here to remedy that. So this is about issues. Let's look to the code itself. So there's about 6 engineers right now on the CDK core team. You would expect us to make commits, right? But it's not just us. In total, close to 500 commits have been submitted by more than 200 people, have worked together with us to build this thing. And that is just amazing response. That is actually almost a quarter of all the commits that have gone into the CDK so far. So I'd like to say this has been a resounding success. we can get it even better. There are some people that I'd like to call out specifically. People like our top 3 change submitters. And this is them. You can see like dozens of commits each. These are people that have gone all in with us in our new infrastructure as code adventure. And every time they were using the CDK and had a use case that the CDK didn't quite support yet, they would just take time out of their day to go and implement it, and then share it back to us so that everybody else can benefit from it as well. And I think that's just fantastic. So big thanks to these people. Let's say you want to join them. And I hope you would, because that's what the session is about. And start contributing as well. We have to talk a little about how it works. If the CDK is doing its job correctly, we hope you can think about it like this. As a user, you work with the CDK. CDK does magic, talks to the AWS Cloud, creates your resources. It's all well and good as a user, but if you want to work on it, you kind of have to know how it works a little. And so it helps to know that CDK uses CloudFormation under the hood to do the actual deployment. What happens from your high-level description? We generate a CloudFormation template, and we hand that off to CloudFormation for the actual deployment. And that is great, because we get all the reliability that CloudFormation has worked so hard on to achieve. We get that for free. We get the knowledge that if the deployment succeeds, all the resources are stabilized and are ready to use. CloudFormation will take care of rolling back to known good configurations if something goes wrong. So we like to think of the template that is used there. We like to think of CloudFormation templates as sort of a cloud assembly language. And we draw the parallel on purpose. Assembly language is very powerful, right? It has all the information. It's the lowest level executable thing. But it's verbose. And you don't necessarily want to write it by hand. And that's where the CDK comes in, to make it easier for you to generate this template. So that's kind of your job if you're contributing to the CDK, right? If you're designing APIs, we're trying to design higher level code and constructs that will translate into CloudFormation that achieves the effect that we want without having to write all that ourselves. And that's what the challenge is, to make that as efficient and as pleasing to use as possible. So let's look at an example. Let's say you wanted to make a bucket and a user, and you wanted to give the user read access to that bucket. Then if you were going to write it in the CloudFormation template language that you're probably familiar with, you would write it like this, right? You have the resources and the policy ultimately that ties it together. Now, from the CloudFormation template language, we automatically generate some classes in the CDK, and we call those the CloudFormation resources. And that is basically just a set of classes that map directly onto what CloudFormation would generate. And if you were to use them, it would look like this. You can see this is roughly the same. The classes that are used in there, the word after new, you can see they start with the letter CFN, and that basically just means they're the lowest level thing that translate directly into CloudFormation. In fact, because it's the lowest level, we also call this the L1 layer. Now, you would say this doesn't give you a lot over writing CloudFormation directly, but it does somewhat, because now you get to use your general purpose programming language already. And that means you get to use the classes, the for loops, the methods that I said. It gives you type checking if you are using a language that supports types. But it can get better than this. Using those level 1 resources, we built something called the AWS Construct Library. You may have recognized it from the title of this talk. And this is where we add the magic that makes CDK so efficient. This is where we really boil it down to just expressing your intent, and the rest just happens. So in this case, it really boils down to just the bucket, the user, and the read permissions. Now, you may have guessed we call this level, this layer, the L2 layer, as it's built on the L1. And this is where all the human work happens. The level 1 is generated automatically, but the level 2, unfortunately, needs the human touch to make the API as useful as possible. So we're in the CDK team, we're working on this. But we really like it if people that are going to be using these resources in their day-to-day job work with us to come up with the best APIs, right? We do our best. We try to understand the services, but maybe as a user, you'll have unique use cases, and we need all that input. We need all that input to make the best layer 2 that we can. So your input can take many forms. At the basics, make a GitHub issue, tell us. Right? Tell us maybe something's not working out very well for you. You want to submit a bug report, say something's not working. Maybe it's a feature request or an enhancement that you need. You have a use case that the CDK doesn't cover for you very well yet.
Well, so, what, like the DynamoDB accelerator?
DynamoDB accelerator, we don't have an L2 construct for that.
No, so I was looking through the CDK documentation, and I noticed that we actually don't have an L2 construct for that.
That's right.
So
I think that's true.
Feels like we should probably fix that.
Yeah, so the first thing you do is, search for an issue, right? If there's an issue already, someone else maybe said, oh, I need DynamoDB accelerator, describe some use cases. Maybe give it an upvote if that is right, to signal to us that you'd like us to work on that, or to someone to work on that.
Okay.
But I checked this morning, and I happen to know there is no issue yet for
convenient.
DynamoDB accelerator. That is convenient, I have to say. So maybe we can go like a step further in this session, and instead of just creating an issue, let's go to an actual change.
Okay, right? That sounds like a great idea.
Right.
So let's flip over to a demo. Let's zoom that in a little bit. Okay, cool. So I've already searched the issues.
Yep.
So the first thing I would have to do is to fork the repository.
Get a copy of the code onto your machine to work on, yep.
Now, I happen to know that the AWS CDK repository is already quite large. It's got a lot of services in it already.
Yep.
So I took the liberty of forking beforehand to make sure that it's done.
Yep.
So to do that, you just click the fork button on GitHub, and that will reclone the repository within your own user account. So I've already done that here, so it actually tells me that I've got a version that's forked into my personal GitHub account.
Yep.
And then I've gone ahead and cloned that down to my desktop. But while I'm here, it's really important to highlight the contributing.md file.
Yes. This will tell you exactly how to go through the process of contributing to the CDK.
Absolutely. So it's a very verbose file, and you might not need to read all of it before you get started, but it's definitely worth skimming through the contents and having a look at what kinds of things in there would be useful for the change that you're trying to do. So for example, it might just be you want to open an issue. It might be that you want to talk about design of a new API. But also it might just be you want to do quick iteration of work, which is something we're going to have a look at in a bit. And also there's some guides in there for particular integrated development environments. So for example, like WebStorm is mentioned there. So it gives you some examples of how to do that. So I've already cloned the repository, and I've already done a build.
Conveniently.
Because I felt that was a good idea. So when you first clone the repository, the contributing file actually points out you need to do a build. An initial build of an initial checkout takes a little time, and I didn't want to take up the time today with that one.
Good preparation.
Yep. So I decided I'd do that beforehand. So how do I even get started then? So I've already cloned all my code. I'm ready to write some. I know TypeScript. Yep. I can write code. So how do I do that?
Well, so I think it's useful to first take a look at the service we're going to be writing the construct for. Can you give us a little? So we're talking about DynamoDB accelerator.
Yeah.
I think what you said. Can you tell us a little about how that works?
Yeah, so DynamoDB Accelerator is a read-through, write-through cache that you put in front of DynamoDB. It sits within your VPC and are managed instances within your VPC. So the idea being that most customers work really well with the sub-millisecond access that you get from DynamoDB, but the cache gives you the sub-microsecond access because of the fact that if you're commonly reading and writing data, it can make it faster.
Right.
But because of that, because it sits within the VPC, it means that it also has to think about security groups.
Sure, right. You have instances that need to be able to connect to each other. You want to control that access. Sure.
Just because they're managed instances, a bit like, say, Relational Database Service, RDS.
Yep.
You have security groups around those, a bit like that.
Yep.
But you have security groups around your EC2 instances as well. And best practice is to make sure that you link those to security group to security group. So rather than using IP ranges, you say that security group A has access to security group B.
Yep.
Yep. But beyond that as well, we also have to think about IAM, Identity and Access Management. We have to think about that because the cluster needs to have access to the DynamoDB tables itself.
Right.
Yep.
And it needs the right IAM permissions to do that, right?
Yep. And then the EC2 instances that my app is running on, that needs to talk to DynamoDB Accelerator, needs to be able to have access to DynamoDB Accelerator running
Right.
on those instances.
So it seems like a bunch of fidgety stuff that we can make better for the user, right? That we can kind of make it automatic for them to work.
Yeah.
Cool. Okay, so let's say, right, you know this service. What would make a good entry point, do you think, as a construct for users trying to use this?
Cluster. Cluster is probably the right point.
Okay.
Because you're making the cluster's the key point to this, I think.
Right. So let's make a cluster construct then.
Okay. So to do that, the CDK is what's known as a monorepo, and monorepos contain a large number of packages within them. In this case, we go to the @AWS CDK package, and in there, if I just list them, there's all the services that you see within the documentation. The one that we're interested in is DynamoDB Accelerator, which is shortened to DAX. So if I load that code up, and then we can have a look at the actual layout of this. Don't worry, I'll zoom it in a bit further. The main file that we're interested in is the already existing generated stuff. So dax.generated.ts contains all of those automatically generated CFN prefix classes that Rico mentioned earlier.
Right, the L1 classes.
Yeah, and those are the ones that are automatically generated at build time for every
CloudFormation resource.
Every CloudFormation resource.
Yeah.
What we then have is an index.ts which exports that file out.
Right, so everything that is available or exported in the index.ts becomes available to users of your library.
Yeah.
Okay. Well, I mean, the simplest thing we can do now, right, I think, is make an empty cluster construct.
Yep.
And then we'll start filling it out afterwards.
Okay, cool. So I noticed very quickly that I didn't delete the generated cluster.files yesterday. That's fine. I'm going to do that now.
Is this not the first time we're doing this?
Yeah,
oh, no.
because it's the repeat.
Ah.
So cluster.ts.
Yeah,
Excellent.
All right.
So how do I go about creating the empty
so the pattern is always the same. You can kind of actually just copy paste it, I think.
Yeah.
It's always just a class that inherits from the class construct. There you got it.
Yep.
It's a class that inherits from the class construct, and the constructor is always roughly the same. It has a scope, which is the parent class or instance you're going to create it in. It needs to have an identifier. And then typically, you want to have configuration parameters for your construct. And those will go into something we call a props variable, and it has a type called construct props. Right?
Yep.
So in this
case,
cluster
props.
Yeah.
So I need to make sure I export this so it's usable. So,
that's very good, yes. Do that first.
And it's something I know we both forget to do all the time.
It's why I always type my closing brace first before I start filling out whatever goes into the closing.
This is really easy to forget to do.
Yep.
So highly suggest the first thing you do when you create your .ts file that you're adding your new construct, the first thing you do is go and do the export, because otherwise you'll be scratching your head trying to figure out why you can't see your new construct when you go and use it. At least that's what happened to me, and I know it's happened to Rico a few times as well.
All the time.
Yeah. So that just gives me an empty construct that we've just, I've got nothing in it though. So what do I do next?
So this is not going to do a lot, but recall the goal is to ultimately generate CloudFormation, and we have classes that will generate the CloudFormation for us, and they're called the CFN classes. Right. So there will be a class called CFN cluster, probably, right? So if we can just new one up of those, there we go.
Yep. And I'll call it resource.
Yeah, that's typically what we do for these kinds of resources.
Yep.
That means it's like the main child.
Cool. Let me just correct my tabbing before I do anything more.
Very important.
Good.
Yep.
Right.
Yeah, so that takes a bunch of properties as well.
Yep.
I don't know what these do actually.
What's quite good about this is that we can look at the documentation straight away. So the documentation that comes in the pop-ups in the IDE will always go to the documentation that's related to it. So in this case, I can click across and it will take me through to that link if Visual Studio trusted it. Conveniently, I already opened the link. So the link it would have taken me to is the AWS DAX cluster, which is the class that, it's the type that CFN cluster is representing.
Yep.
So these properties that exist here are the same properties. Let me just make sure I zoom that in properly. They're the same properties that you would have seen for when I did that control space. So they're exactly the same properties. So some of these are optional, some of these are required. I can scroll through the documentation to find that, but it's also worth noting that when I did the control space in here, it shows me which ones are optional by the question mark that's available there. So when a question mark's appearing there, that is completely optional, and you don't have to do that.
Right.
It's worth remembering, though, that if you look at the documentation, it will tell you what the default is if you don't give that default.
Yep.
Yeah. So there's a few in here that are important. Cluster name description, the IAM role that we talked about.
Yep.
The
I see
node
security
type.
groups in there as well.
The node type's quite important because we need to specify the instance type we want to use. So that feels like, I can see why that's required. Yep. Replication factor is quite interesting because that's the number of nodes that go into the cluster.
Right.
So that's another interesting one. But it feels like we've got a few things here that we can take in and use as properties.
Yeah, I would say the simplest thing we can do now is just take in a bunch of the properties that are interesting.
Yep.
Declare it as our own properties, and then to do the simplest thing, right, just pass them on through to the CFN cluster.
Okay, so let me go grab that because typing all of that out would have taken a bit longer. But let's just move this forward. So the thing we have now is we've now got some properties that represent some of those properties that we have within that CFN cluster. The ones that we feel that the user of our API would want to change. So we have those properties, and then we're then able to pass those across to CFN cluster to be able to build the right thing. Feels like I'm done.
I mean, certainly we have something that probably works. But to make sure, let's give it a build. Let's give it a build.
Okay,
first.
so let's build it.
Yeah.
So, as I mentioned before, building within the CDK, there's a build script that builds the entire mono repo. Right? It looks at all the services that are involved, and it goes and builds every single one of them. But if you're just working on one individual service, you don't need to build the entire repository. You can just build the thing that you're working on and things that depend upon it. So there is a script called build down. Now what build down will do is it will go and look at AWS-DAX and any other libraries in the monorepo that depend on AWS-DAX. There is an alternative script called build up, which does the exact reverse. So it will build everything that AWS DAX depends upon and go the other direction.
So you would normally, if you start working on a package, you would go build up to make sure the package itself builds and everything it depends on, right? And then afterwards, once you've made changes, you'll go build down to make sure your thing builds and you didn't break anything that's downstream from you.
Absolutely. So if I just hit build down, and it's obviously going to pass. Oh, it didn't.
Yeah, this is nothing, you didn't do anything wrong. This is sort of expected. So there are a bunch of errors here. We have some standards around our code, right? To make sure the quality is high, to make sure the constructs can work in a number of different scenarios, and to make sure they're good to use for you. And those rules have been encoded into a tool we call AWS Lint, and that'll run on your code and see if you've conformed to all the things. And there's a number of errors here. I think the most common one will be you didn't add any documentation. And it's very important that everything is documented, because we generate our documentation website from that.
Yeah.
Help your users.
Yes, so everything you see on that CDK documentation site is auto-generated from doc strings within the code. And that is why the linter is doing that job, is to make sure that we can give users at least that information straight away. So it's highlighted not just the doc strings, but it's also highlighted a particular use of the IAM role. And this bit here where it says properties must use strong types instead of attributes. And this is because there are many types of ARNs, but we only want one for a role. And because we only want one for a role, the CDK already has a strong type for a role. It has a class for it. So we want to enforce the use of that role object so that we can make sure we've got the right ARN.
Yeah. If it were just a string, you could pass foo in there, and then it would fill the deploy time, right? We don't want that. We want to give you feedback as soon as possible.
Now, writing doc strings in most IDEs ends up being auto-completed. So you can go ahead and you can fill out what cluster name is and fill out that doc string. And you can also specify things like default. And I don't know about you, but when I first started writing doc strings for things like Python and stuff and things that the autocomplete didn't exist, you sort of have to go up looking up what all the different tags are. But you don't have to do that when you're working within TypeScript. TypeScript actually provides the autocomplete for that stuff. So it's all there for me. But it will take me a while to type all that out.
Yeah,
so
to be fair,
I
would also not accept cluster name as
No,
a
it
documentation for the field called cluster name.
I know. So let's copy those in. And now I've actually got the documentation that says that cluster name is the name of a cluster, and the default is that the name is automatically generated.
See, and that is important, right? The default tells you what happens if you leave the value out. And this is very important for a user. If you can read over the default behavior, and if you go like, that's okay with me, you leave it out, right? There's no guessing. You can just read it.
So the other thing that's worth highlighting is the role. So we talked a little bit about this IAM role ARN, and the fact that we don't really want to pass strings around of ARNs. We'd rather pass actual roles. Now to do that, we declare the role, and then we use iRole. Now that means the interface of the role rather than a role object itself. This means that there could be other types of roles that conform to that interface, and we are therefore just saying we accept anything that conforms to an interface of a role.
Yep.
Now there's one thing I need to do now that I've added that to be able to use this, and that is I've now introduced a new dependency to this library. So AWS-DAX didn't depend upon AWS IAM, but now it does.
Oh, that's right. Yes, because we were taking a string, and now we're taking an object from the IAM library, right?
Yeah. So to do that, because it's a standard Node.js project in this respect, or an NPM package, it has a package.json, and I just need to put in the dependencies that I know I'm going to use. Now, in this case, we've already made use of the @AWS CDK -AWS EC2, sorry, IAM, sorry. And it just needs to match the version string here. So as long as it matches the one above it, that's fine, because when new builds are done and we increment the version number, it goes ahead and it auto increments all of them.
Yep.
I happen to know I'm also going to need EC2 to do some testing later. So I'm just going to add that while I'm here before I forget, because then I'll wonder why it's not compiling. And the other thing the build tool will do is it will update peer dependencies for you. I just sometimes just copy and paste them while I'm here. So the dependencies and peer dependencies should match. The build tool will auto-populate that. But yeah, I just prefer putting it in myself.
Fair enough.
But there we are. So let's have a look at my cluster.ts file now. So I've got IAM being imported. I've got all of my roles. I've got all of this passed in. The other part is that now, of course, CFN cluster was still expecting a string. So it was still expecting me to pass in a string of an ARN of the role. So to get that out of the role, I can use the props.role.roleARN, and that will add the correct reference across to the role's ARN.
Right.
So
I mean, looks good, right?
yeah, I should be able to compile this now,
See
right?
if it builds. Yeah, that's right.
Looking good.
All right. So are we done now?
Yeah.
Did it build? Yeah. So, okay, we got something that works, right? We got something that reps the L1 and is slightly better in that it accepts strong types.
Yep.
But I think now comes the most important part and the most fun part of designing an API. We're not doing this just to make it work. We're doing this to make it a delight to use, right? To make it as good from the user's perspective as possible.
Yep.
So best way to figure out if we're doing a good job is put ourselves in the position of the user.
Okay.
Let's try and use our own cluster construct and see how it feels.
Yeah, let's do that. So what we're going to do that is we're going to use the test folder because everything in the test folder will be compiled, but depending on the prefix of the file name will dictate how it's used in the testing phase. So for example, if it says test dot, it will be done as part of unit test. Integ dot will be used for integration testing, and everything else is just ignored. It's compiled, but it's ignored. So I can create a file in here called example dot, and it will allow me to sort of test out my API and check that the compiling works all the way through.
Yeah, makes sense.
So let's do that and create one called example.cluster as I'm testing the cluster, and we'll call it example.cluster.ts. And then we just need to put in a very basic empty stack.
Yeah, this is, I mean, a regular CDK application.
Yes, this is so this is just a one-file CDK application, which is different to CDK init because that normally does the multiple files. But this is just compressing it into one file so we can have a play.
Yeah.
Yeah.
So I mean, let's try and new up our cluster.
Cool. So my cluster needs a VPC. So let's make a VPC.
Does it?
Yep.
Okay.
As discussed in the diagram before.
Oh yeah, we launch instances into the VPC. Sure.
Yep. So new ec2.vpc. This I can't see under the pop-up. My VPC. That'll do.
Just defaults.
Just a default VPC. Fine. Yep. So that'll create a VPC with public and private subnets using the right number of availability zones for the region that I'm in. Put NAT gateways in. It will do all of that for me. So that was a really quick way to do that. Then I need my CFN cluster. No, not my CFN. My cluster.
Yes, your L2 cluster.
So let's go and make that, shall we? Should we do new cluster? We'll just call it my cluster. And it requires properties. And I've got a red squiggly line. So obviously I haven't got everything I need.
Missing. Yep.
Okay, so it wants node type, replication factor, role, security group IDs. Oh, okay. And subnet group name.
Oh, what is that? I've never seen that before.
Subnet group name is, let's have a look what this is. The name of the subnet group used for the replication, DAX clusters, okay, fine. All the subnets you specify must exist within the same VPC. Well, that's sort of expected. Let's have a look what that is. Oh, there's a separate CFN class for that.
Oh, okay, it's another L1 class that we have to create.
Yes.
Oh, and every cluster is going to need a subnet group, right?
Yeah.
Oh, okay.
So we need to have a subnet group that we can put our cluster in. So okay, we can make one of those. That's fine. So I can just go. I want const. We'll just call this subnet group equals new dax.cfn subnet group. This. We'll just put, I don't know, subnet group for that for now. And then this will want some things. But this is already feeling a little bit complicated, Repo.
Yeah, I'm not liking it very much either.
I feel like I'm having to really dive back to CloudFormation again.
Right.
And I thought the whole point of L2s was that I wasn't doing that.
Yeah. So two things are bothering me here. So first of all, we're letting level 1, right, CFN types escape.
Yep.
Our API, and that's not very nice. We're trying to hide those. And second, every user of every cluster is going to have to make these objects, right?
Yeah.
So why would we make every user go through this? We can just make them automatically for them.
Yeah. And I think there's a few where this is the case. So, subnet group is a good example of this. So we would probably want to put our DAX cluster into a private subnet. Right? So we're only really interested in the private subnets out of our VPC.
We can make
usually.
it configurable. Yeah. But sure, let's say
the role, we probably want to make a role per cluster as well.
Right, role is the same, right? You want to configure your permissions just for that cluster.
Yeah.
Every cluster is going to have a role.
Yeah.
Just make it.
Okay, so how we would start about doing that is going back to our cluster and thinking about how the properties need to change. And there's a few ways of thinking about that. But let's copy across an example of how that looks and then talk through that. So the main thing when we look at the actual construct itself, so the actual code rather than the properties, is that we've now made role optional. We've said, well, it's not really needed by the user of the L2 construct, because if the user doesn't provide it, then we should just make a role for this cluster so that that's the same default thing for it to do.
Right, and you see it, has to be assumable by the DAX service principal.
Yep.
That's a mistake you could make, right?
Yeah.
Let's take that out of the equation.
Exactly.
For you.
Yeah. From the subnet group point of view, we've created the subnet group straight away within the L2 construct. Now, we can actually make this configurable further by putting, say, the type of subnets in here. So select subnets doesn't just, by default, it selects which subnets does it select by default?
So it's private?
Private and isolated if there's no private.
Exactly.
Yeah. But we could go ahead and we can actually specify specific subnet type. So we could put our DynamoDB accelerator in a public subnet. We could put it on a very specific subnet within availability zones or but we've just gone for the same default of, well, it's either private or isolated.
Right.
Yeah.
Let's say we wanted to make this configurable, we could, right? That our optional argument, we can just put that under props and pass it through.
Yep.
For now we haven't, but we can always add that later.
Yeah. And then security groups that we want to have for this is, well, we just need a security group that exists within the VPC or is allocated to this VPC.
Yep.
and then that way, that can then be used within CFN cluster. So this then translates to, it doesn't actually look that different. We're still passing in cluster name description, we're still passing in the role ARM, but we're now using that role that we've created as part of the process. We've also specified things like the replication factor being optional. The documentation says that a good default replication factor is 3. So it says either use 1 or 3, and 3 for production, so 3 is the safe default to put in here.
Yep.
And then security group IDs is a list. So we go ahead and we grab the security groups and make sure we map that in correctly. The other one that's worth talking about is the subnet group name. So subnet group has to be referenced across. So to reference one CFN type from another, you call .ref. And .ref will build the reference in to the CloudFormation output back to the CFN subnet group.
This would give you the same as a ref would give you in CloudFormation.
Yeah, so let's actually go back to our example now.
Yeah, let's see what it looks like now.
So
yeah, we don't need that
we don't need that anymore. So I've got my new DAX cluster. Let's close that. Okay, so I need a node type. So that could just easily be
that seems important. Yep.
dax.t2.large. And I need a VPC. What else does it want?
Well,
replication factor is missing. We didn't make it optional.
we didn't make it optional. Okay.
So nice bug.
Yeah, no, but this is good, right? This is the bare essentials. That is, as a user of cluster, this seems reasonable. I would just want to say, give me some instances of a given size.
Yep.
Replicated this often into my VPC.
Yep.
Into this VPC. Done.
Okay. Feels like we're done.
Maybe, but I think this is a good point to maybe say checkpoint and see if it builds. And if it builds, then let's start making a pull request.
Okay, so that's now we've done some changes. Always a good idea to do a build before you push changes. So let's make sure we do that first.
Oh.
No.
Yes, there's still an error left. Oh, the role did not have a default annotation. So we made it optional, but we did not tell you what would happen if you left the value out. Right? For completeness of documentation, our linter tool will tell you if a thing is optional, you must tell the user what will happen if you don't supply.
By the way, linters are great.
Yep.
Yeah.
They help you not forget.
I can just bypass the linter with that.
Okay. That's fine. I'm going to review your code later on, right?
I know you are.
Okay.
Oh, I see. Okay, it's because so that's just the warning.
Yeah,
they're warnings.
this
I
was
can
the only error,
live with
think.
warnings.
Yeah. The warnings are good to tackle on later as well, but for now, let's make a pull request.
Yep. Okay, so that's now building. Let's wait for it just to finish completely, and then we can talk about pushing this into GitHub. Okay.
All right.
Good.
Looks good.
Okay, let's have a look at what we've got. I got some files I expected to change have changed. That's good. Let's just add those to my commit. Make sure I have only added the things I wanted to add. Good. Let's now commit those. And what do I need to put in my commit message? Rita?
Yeah, so what you usually put in a commit message with one addition. So we follow something called conventional commits, and that means when in describing the title of the commit, you indicate what type of change it is. So you would put fix there if it's a bug fix. You would put feat there if you're doing a feature, as it is in this case. And then between parentheses, you would say what part of the library it applies to. So in this case, I would say DAX, right? And then describe what it did.
Cool.
Yeah. That goes into the title, and then there's a body in which you would go into more detail about particularly why you made the change. And what the implications of the change are.
Construct.
Yeah, so for features, for bug fixes, this is super important. Because in this field, you would describe what the observed behavior was, why it's wrong, why it was happening, why the fix works. For a feature, it's generally, I wanted the feature. So we'll do with a little.
However, so I've made a mistake in this, though. And so it's worth highlighting a slight mistake I've made in my commit message. And this is something that I've personally spoke when I managed teams of engineers, previously to my current role, is really important in Git. is the format of your commit message is really important for 2 reasons. One of them is in GitHub, it will actually highlight it correctly for you if you get the layout correct. The other one is that a git commit is applying something, so we shouldn't really be using past tense.
No.
We should be using present tense when we're talking about something. So a commit doesn't added an L2 construct, a commit adds it. So actually, it's just add an L2 construct and want an L2 construct for a cluster. So effectively saying, well, this commit is applying this change in the present tense. Yeah?
Yep. You would also reference any issues that this change closes, maybe, but since we don't have any, we can skip that and go on.
This is where I get my passphrase wrong.
It's happened before?
It has. I happen to sign my commits, but that doesn't mean you have to. We tend to do it within the core team on the CDK so that it's correctly attributed. But when you're doing open source contributions, it's not needed. So that's why I was signing my commit in this particular case. But I've signed it, I've committed it onto my local branch. It's there, which is good.
All right.
So I can push this, but I need to push it to a new branch to do a pull request.
I mean, that's helpful, right? Because then you can work on multiple things at the same time.
Yeah. So for those of you who've been following along, you'll have seen that I'm working on the master branch. That's what my thing says. Probably shouldn't push to the master branch of my fork. I tend to do this quite a lot by accident. I might want to hack on a new feature, and I tend to just want to go ahead and do it. Some people might, make a new branch, cherry prick the commit across and things like that. Actually, it turns out you don't really need to do that. What you can do is you can just say, I want to push my local master branch to my DAX cluster branch. So the colon means the separation between local and remote with Git. So I can actually say, I want to push master to DAX cluster remotely. The -u means just change the tracking branch locally. So it means my local master branch will now track DAX cluster remotely, which if you're just doing a quick fix or you're trying to just get a quick pull requesting because you've hacked on something, that's a really good way of really quickly doing it.
Yep.
So let me just do that push. And it conveniently provides me a URI to click to be able to go and create my pull request. So I'll just go ahead and click that.
Yeah, that'll take us to GitHub.
If that URL doesn't appear or anything like that, it doesn't really matter. As long as you just go to your fork in GitHub, it brings up like a little yellow banner pop up to tell you that you need to create a pull request or you have a pull request you want to create. So this is showing why that formatting of the commit message was important. It's showing it because the subject is there and the body is there. One of the other ways I like to think about it is it's really a subject and body. It's like the what and then the why and how goes underneath, as Rico mentioned. And it sort of has done that here. When a pull request is opened with only one commit, it automatically populates it with that commit, which is really handy. So I can go ahead and just create a pull request.
Yeah, sounds good.
What could possibly go wrong?
Nothing, it works. All right, so this is good. Your work is kind of done now, and now our work starts in the core team. So we will take this pull request, and we'll go and code review it. First, what's going to happen is some automation is going to run on it. We have a couple of friendly bots that are going to come by and remind you that you need to do a couple things with your commit. You need to put the right subject in. You need to make sure a couple things. I think it's also going to tell you, and something that I'm going to remark as well later on, that you need to add tests and a bunch of other things. So you can go ahead and check that you did that, and your commit's going to get built to make sure everything builds and the tests pass and everything.
Yeah, one of the bots has come in.
Here's the bot that tells you, did you do all these things? So I think our PR description is good, the title's good. Testing, we didn't do that. Documentation. So, and then is my job, and I'm going to tell you, thanks for your submission, right? And don't take this personally, but I think I'm going to make you change a couple things and add them. Right?
Okay.
So this is not personal. We just want the highest quality code that we can get. First of all, documentation, as I already mentioned, is very important, and the bot already told you as well. Mm-hmm. I'd very much like you to add a README to your library. It's not there now, but we use this again in our generated documentation for users that are new to the library. They'll come in, they'll read what the library is about, what the most important classes are, they'll get some example code, right? I'd like you to write some example code to tell a user, this is how you're most likely going to use it, and describe a couple configuration scenarios and everything to guide them through using this library of yours.
Okay.
Yeah. I mean, tests, right? We can't accept any code without tests, obviously, right? So I'm going to ask you to add a couple of unit tests and integration tests.
Want to do that now?
Well, we can have a look.
Let's have a look at an example of one.
Yeah. As an integration test, your example app, right, already works as an integration test, for example. You can kind of just rename that to intech.cluster.ts, and it will run as part of an integration test. You will need to run one more command, and if you run the build, it will tell you what the command is. And it's going to take that application and deploy it to CloudFormation to make sure it actually works.
Yeah. So this is where, this is an example of a fuller test that we would use to test the cluster when we add more features to it, which is just like we would build a table to then have a cluster, and then we would do some things against it to test it. As Rico mentions, we then capture that output. That output then remains static, and we then, in future builds, will test that output hasn't changed to make sure that any future changes to the library don't affect it.
Yep.
That doesn't mean you can't regenerate it. Of course you can, but it just means that you have to have a reason to do that, and that would then get highlighted in the commit.
Right, and it has to still deploy, right?
Okay. So the other thing that we could have looked at with more time to be able to put it in would be to think about how we do IAM and things like that.
I was going to get to that, actually, right?
Yeah.
This is going to come in the review as well. There are some patterns that we follow that are harder to check for the linter, and this comes down to the reviewer, which in this case is me. And I'm going to notice some things as your construct is using security groups.
Yep.
Which, to make it more easy to use for users, we have something we call iConnectable, which is it's an interface that classes that have security groups should implement to make it easier for users to establish, to allow connections between different constructs with security groups. Mm-hmm. Same for roles. And then the thing with IAM permissions at the bottom. So I'm going to make you add all those things.
So what we would do for that, and we won't go through the whole push this time round, is we would go ahead and make the changes that Rico suggests for this construct. And not always though, I might have disagreed with one or two, but it's the go ahead and implement the main features that make sense. So the iConnectable and things like that, they make sense. We should go ahead and implement them. And once you've implemented those, then it's easier for other people to use. It becomes familiar because it's like other constructs in the library. And so those kinds of things are really important to do. But if you disagree with something that comes back on a review, that's absolutely fine too. It's absolutely fine to come back and go, I don't understand why you're asking for that. Like, right. I don't understand why you're asking for iConnectable or iGrantable. I don't understand why you're asking for these things. Feel free to ask back. No one's going to come back at you and go, no, that you're wrong. We'll happily explain why those features are required and why it's better for the library as a whole.
Yep, and this is a fairly simple construct, right? There might be more complicated ones with a more complex interface, and where we'll say, oh, I think the interface might work better if you do this and this and this, and then it's your chances to tell us, no, that wouldn't work in my particular use case, because this example, it wouldn't work. And then we go, oh, sorry, right? Did not know, please tell us, right? And then we can have this discussion.
Cool. So I'm going to flip back to the slides now, and then we can go through sort of what we've learned through doing this and wrap up. There you go.
All right, so we've seen you can help, right? Everything helps with the CDK. You can tell us what we're doing wrong. We use that as a signal, or what we're doing right and what would you like us to do more. We'll use it as a signal to prioritize our work. If you feel up to it, you can even submit the code yourself. We'll do all our best to work with you to get it up to the quality standard we need to integrate it and distribute it around so everybody can profit from this. While you're working, most important point of view of anything you're designing, the customer, right? How does it work? How does it feel? Is it a delight to use? This is the most fun part, I would say. What are the parts you can take away without sacrificing flexibility and the use cases to make it as simple to use as possible, as quickly as possible? And I mean, we've seen this already, document everything, right? You can never have enough documentation on everything. We try to do our best, and we take this documentation that you write and surface it back to the user in the documentation sense, in the documentation website.
Yep.
And then very important, submit early.
Yeah.
If you're unsure about something, please submit it and engage in a discussion. I'd rather you come talk to us and say, I don't know, I think I might want to do it this way or that way, than you spend a whole lot amount of time coding up a particular solution only for us to say like, because of this and this reason, I want you to change it. Because that is, I mean, that's a bad experience for everyone.
Yeah, I definitely prefer the submit early approach. And as someone who's contributed to other projects as well, I find that a good way to work with open source teams. You know, it might be that I don't understand the part of the library or I've misread part of the documentation. And if I've gone ahead and I've spent like a weekend working on something, only to have, because I just didn't know something existed, such as iConnectable or iGrantable,
right.
then you know I've gone ahead and I've built all this stuff out, and then someone's come back and sort of gone no. It doesn't feel very nice, and it makes it a lot harder not to take it personally.
Yep. Well, and that's important, right? It's not about you. It's where we both want the best end result, which is high quality working code that works for everybody.
Yeah.
So that was what we're working towards. If you have been inspired by this and maybe you want to try your hand at something, but you're not exactly sure where to start, or you don't exactly have a use case you want to implement, or you just want to get a feel for the code base first, we have labeled a number of issues in our issue tracker, which you can find there. We have labeled it as good first issue. And that is generally issues that don't take a whole lot of context, will not take any refactoring, generally need someone to understand some details about how a particular service works, and they can be tackled with not too much effort, right? So if you're looking to get started, take one of these. They're great to get your feet wet. And if you want to review what we've talked about, of course this video will be available, but also more in-depth description of everything we already mentioned at the start will be in a file called contributing.md in the root of our repository. Now, if you're interested in more CDK content, there is a wealth of CDK sessions at this reInvent, which is exciting and honestly a little terrifying to see. I can especially recommend, if you want to get into more detail, the top session, DOP 402, which is by our excellent colleagues from the core team, going into some fun edge cases, what you can do with the CDK, and it will go more into the technology that we use to write the CDK once in one language, which is TypeScript, and then make it available to all other languages. We've recently released .NET GA support, which means the .NET APIs are stable, and the Windows people have a session about that to show how you can use CDK in .NET. Our friends from ECS, from Containers, who've been with us almost from the start, made very good use, and they're there in the back, made very good use of the CDK and are super happy with it. They have a session once more on Friday that you can see, and otherwise check it out on video. And I mean, there are too many more sessions. I'm not going to list them all. If you type up CDK into your catalog, like a lot is going to come up. And last but not least, don't forget the CDK happy hour. So we're having a community event tomorrow, Wednesday night at the Link Hotel at a bar called Rematch, no relationship, where we want to get everybody, hear from everybody that's using the CDK or interested in the CDK. The whole core team's going to be there. You can talk to us with questions, concerns, other people. Come meet us. It's going to be fun.
Cool. So thank you very much for taking time out of your schedule this week to spend time with us to learn how to contribute to the AWS Construct Library. We spent some good time going through how to look at issues, how to look at the contributing file, and then actually how to really go about thinking about consumers of our L2 constructs and how to build out new constructs, new features within the CDK, and the kinds of scripts that you get involved in. Up here, we've got our email addresses. It's on purpose. Please feel free to reach out to us directly if you have any questions about what you've seen today, or if you've got any general questions about the CDK. Please feel free to reach out. And last but not least, please complete the session survey in the mobile app. We use these surveys to give us ideas about how to improve content and to make sure that reInvent is good for everybody who comes to it. We'll just flip back to the previous slides. The email addresses stay up for a bit more. Yeah, that's it. Thank you very much, and we hope you enjoy the rest of your week.
Thanks.